Hello, this is Mr. Stansbury. I'm going to take you through the notes on measurement. At the end of this, you should be able to say, I can find the surface area and volume of solids in 3D space. Okay, so just have one example for you here. Example 2, a rectangular pyramid has the base coordinates of 0, P, Q, R, and the apex of the pyramid, or the top of the pyramid, is point A. Part A, sketch the pyramid. Okay, so let's go through and let's graph all these. So 0, 0, 0, that's a pretty straightforward one. That's right here at the center, right? P is 0, -4, 0. So the X is 0, so we don't go out here at all. Y is -4, and then the Z, it doesn't go up or down at all, so there's point P. Just so I'm not sure exactly where everything's going to go here, so let's plot all our points and then we can label all the points with the letters just so we don't get them in the way of the lines. Q is 6 on X, so it comes out here 6, and then it's going to be -4 on the Y, so we come out here 6, and now we're going to move over -4, so basically kind of like here's 4 here, so you want to almost draw like a parallel line out here that comes out to about even with 6, so that's going to be about right there. And then R is 6, 0, so here's 6, 0, 0, so that's going to be right there on that line. And then, so that's the base, so now we can draw that base here. So that base looks something like that. It's the base of the pyramid. Okay, and then the apex is at 3, -2, 7. So we come out 3, 1, 2, 3 is right here. -2 on the Y, so that's over 2. And then up 7. So that's going to be the tricky part. Okay, so like let's say right here, we're about right there. So we're going to go up 7. 1, 2, 3, 4, 5, 6, 7 is about right here. Okay, so as you can tell, this is not going to be an exact art trying to plot points in 3D space. You may actually find it easier to do the Y and the Z first and then do X, the one that's coming at you, last. Might make it a little bit easier. So let's connect all these lines here, draw our pyramid. Okay, so here's roughly what our pyramid looks like here. Okay, so we have sketched our pyramid. Verify that the apex is directly above the center of the base. So let's find the center of the base, which is just going to be, we're just going to need to worry about the X's and the Y's. The Z, the height's not going to really matter too much there. So let's go back and label these points, maybe even put these coordinates on there if it fits. Okay, so here's all of our points with all their coordinates. So we have to verify that the apex is directly above the center of the base. So since it says right here there's a rectangular pyramid, that means this base here is a rectangle. So if we just find the midpoint of either of these diagonals, that will tell us exactly where the middle of the base is. So let's try O is a nice one because it's 0, 0, 0. So let's find the midpoint of O and Q. So let's do that here. B, midpoint of O and Q is going to be this. So let's see, it's going to be 6 plus 0 over 2, -4 plus 0 over 2, and 0 plus 0 over 2. Right, so the midpoint of, not OP, OQ is going to be, that's 6 halves. Let's just go straight to 3. -4 over 2 is -2, and 0 over 2 is 0. So the midpoint of OQ is 3, -2, 0, which is also going to be, has to be the center of the base here. Okay, so all we have to do is check to see if that is, verify that the apex is directly above the center of the base. So that means the Y and the Z, no, sorry, the X and the Y have to have the same coordinates as the apex does, right? So look, we got 3, -2, 3, negative 2, and then this 0 is at the bottom, and then that means that the apex is 7 units up above the center of the base. Okay, so we have now verified that that is true. Find the volume of the pyramid. Okay, so volume, part C, volume we're going to have to find our volume formula. So the volume of a pyramid is 1/3 length times width times height. Okay, so in this case we have 1/3. Say the length here, distance between Q and R. We can use the distance formula, but we can see that the 6's are the same, the 0's are the same. The only thing that's different is it's from 0 to negative 4. So we know that that length has got to be 4. Okay, and then the width, say from R to O. Again, those are both 0's, those are both 0's, so it's from 0 to 6, so that's a distance of 6. And we just figured out that the difference between 3, negative 2, and 0, the base, and 3, negative 2, and 7, that's got a distance of 7. Okay, so 1/2, not 1/2, 1/3. So now we can just go through and we can calculate this volume here. So 1 divided by 3 times 4 times 6 times 7 gives us that our volume is 56. And it doesn't give us any units, so we'll do 56 units squared, because, oh, sorry, not squared, but cubed, right? This volume is cubed. Okay. We have done A, B, and C. Now D, find the surface area of the pyramid. So what we're going to have to do is we're going to find the area, surface area of the base, the two sides, like the right and the left, those should be the same, and then the front and the back should also be the same. So we just got to find the surface area of all of those. So let's do that here. So we want to find the surface area. Oops. Is going to be the base plus the left and right, which are going to be the same, left side and right side, plus the front and the back, which are also going to be the same. So let's find each one of those. Area of the base. So we just figured out that this distance from Q to R, that was 4. So the base is going to be 4 times the depth here is 6. So 4 times 6, that's the base. Left side or right side. So we know that the base here, so this is the area of a triangle. So this is going to be, and they're both the same. So let's do this. 2 times one of those triangles. 1/2 the base, which we know here from 600 to 000 is 6. 1/2 times 6 times, now we have to do the height, which is this diagonal piece right here. So we actually have to go through and calculate what that height's going to be, right? So we can do that with good old Pythagorean theorem here. So this is going to be one that you have to try to visualize a little bit. So if we draw this, like here's the center, right? So if we draw this little dotted line straight out here, and we're looking for this, pretend that that's straight. Not very straight, but you get the idea. So that is, this diagonal is the piece that we're looking for. And we know that straight down here, we just figured out that that's 7. So this is in the middle, so that's going to be half of this distance all the way across. So this distance all the way across is 4. So if we draw this triangle off here on the side here to maybe hopefully make this a little bit easier, we have this. So picture this right here. This is this triangle. So we just figured out the height was 7. We know that's got to be a right angle. This is going to be half of this length here, which is, that whole thing is 4, so half of that's going to be 2. So now we can just do 7 squared plus 2 squared is going to equal, we'll call this, I guess, C, equals C squared. So we got 49 plus 4 is C squared, so that's 53. So, oops. So C is going to be square root 53, right? So let's do this. Let's just leave that as plain old square root of 53. Okay. 1/2 the base is 6, the height is root 53. And then we got to add on the front and the back. So we got to do the same thing because this diagonal here is not necessarily the same as, not diagonal, but this length right here is not necessarily going to be the same length as this one on the side. So got to do the same thing here. So that's the middle. So now what we want to do, let's try this in maybe a different color. Maybe that'll help. So now we have this line here, and we're going to look for, we're trying to calculate this diagonal piece right here, and all the way down to, oops, that goes all the way into there. And so now we have this base. So then let's redraw that triangle over here. So there's the slant, there's the height, and there's the point from the middle of the base out to this side here. So this side right here we know is going to be half of this length. We know that whole thing is 6, so this would have to be 3. This height is 7. So then let's call this C again. So we'll do 3 squared plus 7 squared equals C squared. So that's 9 plus 49 is C squared. So that's going to be 58 is C squared. So C is going to be the square root of 58. Okay, so that's going to be, let's change our color back here. So this is going to be twice these two triangles, which is 1/2 the base, which this base, entire base here is 4, times we just figured out this height right here is the square root of 58. Okay, so I'm going to calculate all that, add them together, and we've got our total surface area of our rectangle. So we've got 4 times 6. We know that that's 24 plus, and then let's do our 2 and our half are going to end up turning into 1, so we don't have to do that. We don't have to do that here either. Okay, so it's really 6 times the square root of 53, which gives us 6 root 53. Not helpful. 43.7, we'll call that. So remember, that's for two sides. That's the right side and the left side. And then let's find out 4 root 58. 4 times the square root of 58 gives us 30.5. Let's call that, round it off. So now we add all 3 of those together, and then we are done. 24 plus 43.7 plus 30.5 gives us 98.2 units squared, since we're talking about surface area. Okay, all right, that's all there is for that. I know that's kind of a entailed problem there, but we're able to find surface area and volumes of solids in 3D space. So if you have any further questions about this, please feel free to ask in class. Thanks.